Hello, everybody. Welcome to the Neo4j online meetup. Sorry, we're a bit late starting, but we're ready to go now. So we're going to be doing, so I see there's a few of you already in the comments. Excited about this one? Yeah, so we're excited as well. So this should be fun. If this is the first time you've joined a YouTube live stream, when Will shows code, you might want to make sure that your quality is set to 720p. That's in the bottom right-hand side of the screen. Any questions, just ask them on the right-hand side like you're doing already, and I'll pass them on to Will. And with that, I'm going to hand over to Will and GraphQL with Neo4j. Over to you, Will.
Thanks, Mark. And hi, everyone. Welcome to the Neo4j online meetup. Today, I'm going to be talking about querying graphs with GraphQL. We're going to look at building a GraphQL API backed by a graph database. So my name's Will. I'm on the developer relations team at Neo4j. Feel free to reach out on any of these contact points here, email, Twitter. I blog occasionally at lyonwj.com. My role at Neo4j is primarily helping others be successful with Neo4j. So I do this by helping to build integrations with Neo4j, with other technologies, doing trainings and workshops, but spending a lot of time with users, understanding how they're using Neo4j and trying to make that experience better. So today we're going to talk mostly about GraphQL, but I do want to spend just a little bit of time giving a brief overview of Neo4j so that we're all on the same page. And then we'll dive right into GraphQL. We'll do sort of a survey of GraphQL, the ecosystem, what GraphQL really is. And then I want to talk about why I'm really excited about building applications with both GraphQL and graph databases. I think there's a lot of benefits to using these two technologies together, which we'll talk about in a minute. And then finally, we'll look at some examples of how we can actually build applications that use Neo4j and GraphQL. We'll talk about a couple of different approaches. We'll look at integration that we've been building on the Neo4j team, how that's going, and we'll take a look at how we can improve that going forward. So with that, let's talk just a little bit about what Neo4j is. And I think the best way to introduce something, to summarize it concisely, is in the form of a tweet. So here's Neo4j in 140 characters. Neo4j, open source software that stores and queries data as nodes and relationships using the cipher query language with index-free adjacency. So there's a lot in there. Let's unpack that a little bit. So Neo4j, of course, is open source. The code is on GitHub. You can pull it down, build it from source. You can download Neo4j to get started. It's also available as a Docker image, Debian package, and so on. So very easy to get started with Neo4j. Neo4j allows us to store and query data. So Neo4j is primarily a database. It's a transactional database. Once we have committed a transaction to the database, that data is durable and safe. And Neo4j allows us to store and query data as nodes and relationships. So on the right here, we have an example of a graph data model. We can see nodes. These are the entities, the objects in our data model, and relationships connect them. So this is the basic data model that we use. And of course, this example comes from the Panama Papers. So the Panama Papers, this was a data set that was leaked to some investigative journalism group from a Panamanian law firm. They used Neo4j to make sense of this data to determine what entities were registered in offshore jurisdictions, who were connected to these various entities, did they share addresses in common, this sort of thing. By the way, this data set is available for download as a Neo4j database. It's very interesting to explore. The next part in our tweet here is that we allow to store and query data as nodes and relationships using the cipher query language. So cipher is the query language that we use with Neo4j, You can think of it as SQL for graphs. Cypher is all about pattern matching. So in this example here, we're defining a graph pattern that we want to match on, a pattern we want to find in the database. In this case, we're looking for addresses that contain the string New York. We're then traversing from that address to find officers that have a registered address in New York. And then we're traversing from those officers to find legal entities that they're connected to. So this query says, for everyone that has an address in New York, what legal entities are they connected to? And if we ran this query in Neo4j browser, which is a developer tool, a query workbench for running and visualizing the results of Cypher queries in Neo4j, we would see a graph visualization like this. So we can explore the data visually. We can see clusters where we have lots of interconnected people and entities. But sometimes the result that we're looking for, the answer to our question, is an aggregation. Sometimes it's tabular data, not graph data. So maybe we wanted to ask the question, what are the most popular offshore jurisdictions for people with addresses in New York? Well, we just modify our query slightly, and in this case, we're returning an aggregation, so the result of the count function, grouped by jurisdiction, and we get tabular data. So we can see for people with addresses in New York, the most common jurisdiction for them to register offshore entities is the British Virgin Islands, followed by the Cook Islands, and so on. So those are just a couple of examples of how we can use Cypher. Cypher, of course, is an open source query language. It's used not just by Neo4j, but several other graph projects as well. And the final piece of our overview tweet here has to do with index-free adjacency. Index-free adjacency is a very important property of graph databases related to performance. What this means is that when we traverse the graph, so when we move from one node to any other node that we're connected to, we don't use an index. Rather, we have a direct pointer, essentially. So we're doing pointer arithmetic, which computers are very, very good at. So that's a very, very fast or constant time operation. It's not dependent on the overall size of the data. So that allows us to scale our queries to very, very large data sets. So that was just a brief overview of the concepts and the important features in Neo4j and graph databases. I would really encourage you to try out Neo4j Sandbox. The Sandbox allows you to spin up Neo4j instances with preloaded data sets. It has some great interactive guides to walk you through different use cases, and this is available on neo4jsandbox.com. We'll be doing a little bit of an example with GraphQL using the sandbox in just a moment. Okay, so that was Neo4j. Let's switch a little bit to talking about GraphQL. So what is GraphQL? Well, I think the simplest way that we can talk about GraphQL is as a query language for your API. We'll see what that means in a moment, but I think it's helpful to understand the origins of GraphQL so we can understand what features are built into GraphQL. So GraphQL was originally developed by Facebook, inside Facebook, for their native iOS and Android apps. And it was designed to solve some specific issues related to using REST APIs with native mobile apps. So the first problem that Facebook wanted to solve was reducing the number of round-trip requests on their native apps. So on mobile, especially on cellular networks, we know that requests have very, very high latency. And so what we want to do is reduce the number of round-trip requests that are needed to render a given view. We want to just ideally make one request to the server to render a view. We don't want to have to make multiple requests. But with typical REST APIs, we end up maybe getting back a list of objects from a REST API, and then we need to make multiple requests, maybe to hydrate each object, something like that. So we need to just make one request to render a view. And we also want to state just the fields that we want to be able to render that view for the application. In REST, typically, we aren't able to select just the fields we want. We send back a large JSON or XML document, and this is what we get back. Rather, with GraphQL, we want the client to be able to say, well, I just want this field, and that's all I need to render the view. So GraphQL is a declarative alternative to building REST APIs. GraphQL is self-documenting. So we define types, we define a schema. This essentially then becomes the blueprint for the API so that the client knows what data it can request from the server. GraphQL actually has limited support for what we would think of queries in a standard query language. So for example, filtering, aggregation, support for those are very limited. Rather, this logic is implemented in the server in resolver functions, which we'll see in a minute. So one way to think of GraphQL, and this comes from the graphql.org website, that GraphQL is a query language for your API and a server-side runtime for executing queries using a type system you define for your data. So note that there's a very heavy emphasis there on the type system, defining your schema, and then defining how to fetch that data. So GraphQL is not tied to any specific database or storage engine. We can use GraphQL with any database. We can even wrap existing APIs with GraphQL, and we can wrap multiple of these and serve them in one GraphQL endpoint. So we create a GraphQL service by first defining our schema and our type system. Then we provide functions for how to fetch this data for each field. These are called resolver functions in GraphQL. So GraphQL has been adopted very quickly since it was open sourced by Facebook about 2 years ago. So we've seen GitHub, Yelp, and Shopify release public APIs, GraphQL. And we've seen a number of other companies using GraphQL for building their applications and also for their internal APIs. So let's take a look at an example. Here's a simple GraphQL query. We're essentially looking up a business by ID. So we pass in some ID as an argument, and we specify the fields that we want to get back for this business: name, address, city, and so on. Now note here that we're also saying we want categories, which is going to be a array of names. We may have more fields on category. We may have an ID, a long name, a description, something like that, but we're only grabbing the name field on category. So it's important to note that GraphQL makes the observation that your application data is a graph, and you can specify a piece of the graph that you want to pull out and render to the client. So in this case, this is essentially the graph that we're requesting from our application data, business, which has some fields, categories, which also has some fields. In this case, we want the name field. And here's what this result would look like. The result comes back as JSON with a top-level data attribute with the results of our query. So note that we're specifying the shape of our result in our query. I think it's important to understand some of the tools in the ecosystem around GraphQL. So let's talk about that for a moment. So of course we need GraphQL clients. These are what send requests to our GraphQL server. The most popular GraphQL client, I think, is Apollo client. There's also Relay, Relay Modern, which Facebook recently released at F8 earlier this year. Apollo client also has iOS and Android clients. And then there are a few other lightweight clients as well. Typically, these are used with front-end JavaScript frameworks, so React as an example. But again, there are others that are commonly used with GraphQL. One thing that I think is really interesting are some of the GraphQL as a service companies that are providing GraphQL backends, like GraphQL, Scaffold, and Reindex. GraphQL is doing some really interesting things, I think, to innovate GraphQL. We can look at some of the more popular languages that people are using with GraphQL. I think because of GraphQL coming out of sort of the React ecosystem and Facebook, JavaScript is very popular. But of course, we're seeing Swift and Java for Android emerging as well for people using GraphQL clients. Now, that's not quite the same case with folks building GraphQL servers. There are GraphQL libraries for just about every language now. Of course, with our Neo4j integration, we use the Java GraphQL library. But JavaScript is quite popular with Node and Express. And we have other tools such as Graphical, which we'll take a look at in a moment. This is sort of an in-browser explorer for a GraphQL endpoint. Another project by Apollo is Apollo Optics, which has great tools for monitoring performance. One thing that's really interesting about GraphQL is that we can get performance level metrics on each field, which can tell us what queries are holding up rendering our GraphQL result. We can inspect those. And then data loader, which is used for batching requests to, again, improve performance with our GraphQL queries. So if we think of what a stack might look like for building a full stack graph application, we may use GraphQL, we may use React on the front end, we may use Apollo as the client, or even Apollo server as the library for our server. And then of course we need some database. So this is where Neo4j fits in. So these are sort of the components of what we might think of a full stack graph application. One thing that's really important in the GraphQL ecosystem is this idea of GraphQL first development. So we talked about this idea of designing a schema that defines our types that we're allowed to use, and then this becomes the blueprint for our API. And that's really what GraphQL first development is all about. It starts with the schema. Once we've defined the schema, we can then easily mock those so that the front-end developers can build the front-end application while we then build the rest on the back end. So the schema becomes the blueprint for our API. Everything starts with the schema. Now, how do we define our schema? Well, we use this IDL schema syntax. And this is sort of a shorthand for defining our types in GraphQL. It's, of course, language agnostic. And we can use this in tooling to sort of scaffold or mock our server. So you can see here, we're defining types, and we're defining fields on each type. We can see here we have users, we have posts, a user has multiple posts, and so on. We also have mutations defined in this schema. We won't talk about mutations too much. We'll see an example later on, but basically a mutation is a write operation. So this is how we update data using GraphQL. Let's look at a simple example here. One of the things that that we know that Neo4j is very good at is combining data from multiple sources and then querying across those data sets. So we built what we call the GraphQL community graph. This pulls in data from Stack Overflow, Twitter, and GitHub. We pull that in live from those APIs into Neo4j. And then we built a GraphQL endpoint that sits on top of Neo4j and serves this data in one unified GraphQL schema so that we can query for, say, who has the most popular Stack Overflow post for the week and look at their tweets and so on. And this is open. It's running live now, so you can access this at graphql.communitygraph.org and play around with this. Let's see what this looks like. We'll use Graphical, which I mentioned earlier is this in-browser IDE for working with a GraphQL endpoint. So one thing that's very, very important and very nice in Graphical is we can easily inspect our schema. So we can see the types that we have available. So we can see here that we have data from Twitter, Stack Overflow, Meetup, so we can see events, infrared venues. We have GitHub repositories, users that are connected to these repositories, and so on. Let's make a simple GraphQL query here. Let's query for a user by screen name, line WJ. We'll pass in as the argument, so that's me. And then once we find that user, we'll grab screen name, the name, and then posted. So these are all the tweets that I've posted and just the text property on each of those tweets. Now, each tweet has many other fields. We can also grab any users that are mentioned in those tweets. So we see a tweet that mentioned Graph Day in Neo4j, another one that mentioned APIs Guru in Neo4j. And of course, for each of those, we can also grab any tweets that user has posted as well. So we're just traversing the graph here. Great, so that's just a simple example of how we can query data using GraphQL and Graphical, which is a great developer tool. Let's now back up a little bit and talk about how do we build a GraphQL server. And specifically, how would we use Neo4j with GraphQL to build our GraphQL server? So again, this goes back to this idea of GraphQL first development. Everything starts with the schema. So the first thing we'll do is define a GraphQL schema. I'm going to shift domains a little bit and use movies as an example. So here's a very, very simple GraphQL schema. We just have one type of movie that has a movie ID, which is a required string. And then we have things like title, year, plot, poster, which is some URL for the poster image. We have some rating. We have genres, which is just a list of strings. And then we have this similar field. So one thing that we know Neo4j is very good at is for generating personalized recommendations. So one thing we can do is say, well, for a given movie, if you're interested in this movie, what are some other movies you may be interested in? And we can do that by finding similar movies. So in this case, we're going to add a field on movie that will evaluate to a list of movies that are similar, maybe good recommendations for people who like this movie. And then we can also define queries. So we'll define a movies query here that takes a substring and a limit that evaluates to a list of movies. So we may need to say search for movies by title, and we just want to type just a part of the title and then search for movies that match that substring. So the next step then is to define our resolvers. Remember, our resolvers are the functions that are responsible for fetching data for a given GraphQL field. How do we do this? Well, here's an example for our movies query. Remember, we said that our movies query, we were going to take a substring and then search for movie titles that contain that substring. So in this case, in the movies resolver function, we're passed in the parameters, so the substring and limit, the number of movies we want to find. We create a session object. This is a connection to Neo4j in this case. We then define our query, which is a parameterized query. It's going to take substring and limit as a parameter. And then we return the results of running this query against Neo4j to find the movies that match this substring. So let's see an example of this running. This is going to use the Apollo Launchpad tool. This is a really neat tool that allows you to really easily build GraphQL servers, and then it also bundles graphical, and we can see the results live as well. And again, this is running live as well, so you can play around with this. But let's take a look here. So on the left there, we've defined our simple GraphQL server. We pull in the Neo4j driver as well as some GraphQL tools library from Apollo. And then here we've defined our schema. This is the simple schema that we saw on the previous slide. And then the next step is to define our resolver functions. So we saw that example of the movies resolver function where we're searching by substring. We also have our similar resolver function here. In this case, the cipher query that we're using is just finding movies with an overlapping genre. We could make this more complex to look at user reviews, people who liked this movie also liked this other movie kind of thing, but I think you get the general idea there. Now, once we've defined our resolver functions for our schema, we can then run a simple GraphQL query. So on the right, we have graphical embedded into this Apollo Launchpad tool, and we can query the movies query, passing in substring matrix limit 3. So we want to find 3 matrix movies. And then we want to grab title, genres, plot, and year. And we can see we find, okay, each of the 3 matrix movies. But now, of course, we may want to generate recommendations for people that like these movies. So we'll grab the similar field and we'll grab the title of the similar movies. So you can see here, if you like The Matrix, other similar movies are X-Men Origin and the other Matrix movie. Okay, so that's just a simple example of how we can build a GraphQL API. What could we do with that with, say, a simple React application? Well, here's our simple React application looking at movie data. So we can see we're presented with a list of movies. We can select a movie. And then once we select a movie, we then run that similar query to find movies that you may be interested in that are similar to the movie that you clicked on. So again, a simple example in React that's querying, this is actually querying the exact Apollo Launchpad endpoint that we defined earlier. There are a few observations here that I'd like to make as we think about building a Neo4j GraphQL integration. So with that in the back of our minds, let's make some observations. So really, GraphQL is not a query language for graph databases, but GraphQL does make the observation that our application data is a graph, and GraphQL allows us to define and query it as a graph by extracting trees, right? We specify the data from the graph that we want, but we're not using a graph database on the back end. Well, this implies that then there's some mapping or translation layer, and this actually hits our resolver functions. They have to basically take the GraphQL query, translate that to SQL or to some ORM, map and translate that query. Another observation, GraphQL is designed to be bolted onto an existing data layer, right? We already have an API for a resolver function to hit. We already have a database for our resolver function to query, which means that we have to write these queries ourselves in the resolver function. And this can result in many different queries. For a complex GraphQL query, we may have one query for each field. So in the previous example, we were just using the Neo4j driver for JavaScript to query Neo4j in our GraphQL resolver functions. This is how we would use GraphQL with any other database. So we thought, well, is there a better integration that we could build? Is there a way that we could make building applications using GraphQL and Neo4j a better experience for developers? So what would that look like? Well, if we're assuming that our application data is a graph with GraphQL, why not model and store it as a graph? So if we do that, then the graph database removes this mapping and translation. And why then, for each of our resolver functions, for each of our fields, why would we have to write the query ourselves? We should just be able then to translate GraphQL to cipher, in this case with Neo4j. And we should see a performance benefit of storing our application data as a graph, but also if we translate GraphQL to cipher, that's just going to be a single cipher query that we send to the database rather than having to batch a bunch of, say, SQL queries instead. And the final piece that we wanted to explore in this GraphQL Neo4j integration is cipher. So we said earlier that GraphQL is actually fairly limited in query language features, things like aggregations, filtering. What if we could expose cipher, query language for graphs, through GraphQL to really enhance the power of your ability to query with GraphQL? So the thought here was, well, what if we could embed cipher within our GraphQL fields? So we'll take a look at this in a moment. What we came up with. This is sort of the rough architecture of what we wanted to build. We wanted a command line tool that made this very, very easy for spinning up GraphQL endpoints backed by Neo4j. We wanted to be able to scaffold some client code. And then we wanted to leverage Neo4j sandbox. So we built a GraphQL extension for Neo4j that serves the GraphQL endpoints. It's code that's deployed to the database. So Neo4j then becomes the server for your GraphQL endpoints. And this command line tool allows you to easily deploy a Neo4j sandbox instance, push your schema definition to this, and then you're immediately serving the GraphQL endpoints from Neo4j. And you can do this from Neo4j sandbox or your own instance running locally or hosted somewhere else if you just install this Neo4j GraphQL extension. So let's take a look at those benefits that we mentioned before. This idea of storing data in a graph database removes this mapping and translation layer that we have to define in our resolvers. This performance benefit of translating GraphQL into a single cipher statement. And then cipher. So exposing cipher. We thought about different ways of how we could expose cipher in GraphQL. And what we found best that fit within the specification for GraphQL and all of the things that you would want for someone building GraphQL applications, we decided to expose cipher through GraphQL schema directives. Now, a directive is a way to annotate a field. And in this case, we've introduced a cipher directive. So note here the recommended field on user with the cipher directive. We have a cipher statement as that sort of annotation. And what this means is that the result of this field maps to the result of that cipher statement. So rather than just looking up a recommended field on some object, instead we run this cipher query that in this case is for a user looking at the movies that they've rated, other users who have watched this same movie, what are the other movies these other users are watching, and these are movies you may be interested in. So a simple collaborative filtering movie recommendation. In this case, we can add to your GraphQL schema with just one simple directive. We thought this was really, really powerful. Let's take a look at how this works. So this tool is available on NPM, the Neo4j GraphQL CLI package on NPM. Let's start with a bit more complex version of our movie schema. We've added now a genre type rather than an array of strings. We've also added actors, directors, and then now our similar field. Previously, we had to define this in our resolver function where we had to create a session to Neo4j and we had to iterate through the results, but instead we can just add the cipher annotation here to our schema. And let's see how this works. So the first thing we'll do is npm install Neo4j GraphQL CLI. This will bring this down from npm. Then we use the Neo4j GraphQL command, passing in our movie schema that we just defined. And this will redirect us to Neo4j sandbox. So Neo4j sandbox, we can authenticate. In this case, I'll use Twitter. But we can also use GitHub or other social networks or create an account. Now what this is doing is spinning up a Neo4j instance and installing the Neo4j GraphQL plugin. It'll take a moment. It's using Docker on AWS. Now once this is online, we will have now our GraphQL endpoint served by Neo4j on Sandbox. And we'll also have access to GraphiQL, that in-browser IDE tool. So we can open GraphiQL and we can see that we have our schema that we can explore. Of course, we have no data. So the first thing we need to do is execute some mutation operations to add some data. So we've just added some movies and actors there. And now that we've added some data, we can actually query. In this case, let's look for Tom Hanks, the movies that he was in, and then for each of those movies, let's find similar movies that we could recommend. So we're saying that Forrest Gump is similar to Apollo 13 in that example. So that's the Neo4j GraphQL tool. It bundles the Neo4j GraphQL plugin that's also available separately. If you don't want to use Neo4j Sandbox, there's more information on the developer page about this tool as well. So I'd really encourage you to try that out. Spent some time with users getting their feedback on this integration that we've built so far. And we've had some really good feedback that I think can inform our next steps for the next version of this plugin. And so far, what we've found is that, of course, one of the benefits of GraphQL is that we can use any data source to integrate data into a single GraphQL schema. So we want to ensure that we're able to do that with our integration, allowing for multiple data sources, not just for Neo4j. We found that oftentimes folks wanted to be able to define custom resolvers. Now you can, with our integration, you can define some business logic in Cypher, but often you want to have some more explicit code for defining custom resolvers. Maybe you want to override that default GraphQL to Cypher translation with some custom logic of your own. And we also found that people wanted to ensure that this works well with their common GraphQL server tools, things like Apollo Server and GraphQL JS, the reference implementation of the GraphQL server. So with that in mind, what we're working on now is essentially a JavaScript library that translates GraphQL to Cypher, creates your resolvers, but allows for overriding of any of those resolvers to define custom business logic, something that works well, drop in with Apollo Server and GraphQL JS as well. So this is the next step that we're taking. If you have any feedback or any ideas, there's a short survey. The link there is bit.ly/Neo4j GraphQL feedback. Or you can also email me directly, will@neo4j.com. I'd really love to know, what do you think of this integration? What do you think of GraphQL? What do you think of GraphQL and Neo4j together? Please reach out. We're sort of in the phase of making sure that any integration that we're building fits the needs of the users. So if this is something that you'd like to provide input on, really please do it. It helps us inform what we're building. So I mentioned this a little bit at the beginning, but again, GraphConnect, the annual developer conference for Neo4j, is coming up in October in New York City. For anyone on the online meetup, there's a promo code that you can use, KW30, which is good for a 30% discount now through the end of Saturday, I believe. So I'd really encourage you to come to GraphConnect if you're able. It's a 2-day event. The first day of tutorials, training, executive summit. There's a hackathon the first day. And then the second day, hearing from lots of Neo4j users. We have a hands-on graph clinic as well as a developer zone to see what folks are building with Neo4j. So I'd really encourage you to come to GraphConnect in October if you're able. And with that, I think we may have some time left for questions. Okay, great. So will there be beer at GraphConnect? Yes, there will be, of course. One of the big events there is the Graph Party. And of course, we have the hackathon as well. So certainly check that out. So the first question we have is, would you be able to recommend a server type or language for GraphQL if you had a free choice? Node.js, PHP, Python, etc. And if so, why? Yes, that's a good question. I think given the way that GraphQL was released and developed in the ecosystem, it started largely around the JavaScript community, coming largely from its use at Facebook, and then with React. So I would probably start with things in the JavaScript ecosystem. I mentioned Apollo Server. That was the example that we looked at in Apollo Launchpad, which is a JavaScript library that allows us to define our GraphQL server for starting with our schema and then defining resolvers. So I would start there. JavaScript, Apollo Server, probably sort of a wrapper for GraphQL JS, which is, of course, Facebook's reference implementation of GraphQL. Question from Stefan here. Can I do multiple searches on a mutation? For example, person, name, user1, user2. Yes. So so you would just have to define your resolver such that it's taking argument of an array there instead of just a single string. So it's just logic that you would need to implement yourself in your resolver function. Another question here, does the Neo4j GraphQL tool only work with the sandbox, or can we run this against a deployment? Yeah, that's a great question. So the command line tool that I showed initially, that's tightly integrated with the sandbox. So the goal of that was just to be able to allow developers to spin up a Neo4j GraphQL stack very, very quickly and easily. But of course, you're not forced to use the sandbox with this integration. Neo4j GraphQL is a extension for Neo4j. If you look at neo4j.com/developer/GraphQL, then that has all the information for how you can deploy that extension to your own instance of Neo4j running locally or deployed anywhere else. And we are working to upgrade that command line tool so that we can specify a instance not just in Sandbox, or also tightly integrated with Docker as well if you want to spin that up. So the short answer to your question is no. You can use that that integration with Neo4j running anywhere. Okay. One more question here. If we add a cipher query in the resolver or use the @cipher directive, is it still going to make the same number of queries to the database? How is that different? Yeah, that's a great point that you bring up. So, so in a typical implementation of a GraphQL server, you may end up with one query to the database for each field. And you would use a tool, I mentioned this earlier, a tool like Data Loader to be able to batch these queries so that you have some good performance. The performance benefit of translating GraphQL to a single cipher statement is then that's only one query, that's only one round trip to the database that we have to make for that query. Also, the plugin runs in the same JVM as database, so of course that's going to be a bit more performant also. Another question here. Do we have an ETA on any of these future iterations? Yeah, good question. So so the demo that I showed, right, those features are all available now. And then the things I talked about looking forward, so for example, improving the command line tool to work with other deployments of Neo4j, and the JavaScript library that's going to be a drop-in implementation to work with Apollo server. Those are the next things we're focused on. We've just started development of that JavaScript library. So I imagine we'll have something of sort of alpha quality for that in the next few weeks available for testing. If you're interested in testing that or informing our design of that, please reach out to me. We'd love to hear from you. Another question here, is the GraphQL language type as flexible in handling things like Java or more rigid in what I can pass and create? So we said that GraphQL requires you to define your types and define your schema, and that does impose some rigidness. Some see this as a benefit, some as a disadvantage. I was chatting with a user earlier this morning about how that applies to Neo4j. I think it's actually one of the benefits of working with Neo4j and GraphQL together is that you have embrace the schema, and that allows you to have clearer idea of what's available on the client. Anyway, your question was specifically when I define my types, how flexible is it? So really, it's just a matter of implementing your logic in those resolver functions. So you define your types. You can have as many types as you want. Those types can have fields that map to other types as well. That's where the graph piece comes in. And then the logic behind that is up to you, however you want to define that in your resolvers. The type definition allows for specifying things like required fields. You have some base fields, things like IDs, strings, integers, and then you can define your own types beyond that. Another question, is there a direct relationship between the IDL schema from GraphQL and the way types are maintained in Neo? Yeah, so that's a good question. So what you're getting at is essentially how do we map your GraphQL schema to a property graph model in Neo4j? So if you're paying attention, they're not exactly a perfect one-to-one match. And the answer is that we apply some rules. So every type that you define becomes a node label in Neo4j. I didn't mention this, but we also have a relation directive that we need to define. So any relationships that we want to define in Neo4j need to be annotated as well with this relation directive that helps us inform exactly what's going on with mapping that to the graph model. Another thing that we do is we infer mutations. So we mentioned this just a little bit, but mutations are GraphQL queries that allow us to do updates. So from your GraphQL schema definition, we infer some mutations that allow us to create data in Neo4j that maps to your GraphQL schema. And another question here, are the parameterized queries against Neo4j protected against what amount to be SQL or cipher injection? So for example, bind variables versus inline substitution. I would hate to see a detach delete in there. Excuse me, yes, exactly. So that's the benefit of using parameters in Cypher, not just sort of concatenating strings, is that we're able to avoid that. So we use parameterized Cypher queries, in this case, using the Java library for Neo4j to avoid that. Will the JavaScript library you mentioned require Neo4j GraphQL installed on Neo4j instance, or is it my own thing? Yeah, that's a really good point that you bring up. So we want to make sure, essentially, that you can use this GraphQL JavaScript library with Neo4j without having to install a Neo4j plugin. This would allow you to just use the standard connections to Neo4j. So the goal moving forward will essentially be to take out the logic of how we translate GraphQL to Cypher into a JavaScript library, bundle that with the JavaScript driver for Neo4j, and package that in a JavaScript library that works well with Apollo server and essentially creates your resolver functions just by inspecting your GraphQL schema. Great. I think that's all the time we have today. So thanks everyone for joining. It was really good chatting with you all, and we hope to see you next week at our next online meetup.
Cool. Thanks all, and thanks everyone for joining, and we'll see you this time next week. Bye.